This is a question about converting a log expression away from logs in a way such that we can solve it and find a value for x which satisfies that equation. I've popped on the log laws on the same page to help us, so let's have a go at it. First thing to notice is it's all base 4, so we'll be able to merge these two different logs into one single log expression, also to base 4, and then get rid of the logs. So looking at this first term, we can move the multiply by 2, which is sitting out the front here, to become an index of the bracket by using the power rule. So we get log to the base 4 of 2 minus x squared. Now the rest. Now, looking at this subtraction of two logs, if we use, again, the reverse of the division rule, we can merge these two terms into a single log expression of a fraction. So I get, therefore, the log to the base 4, this guy on the top, which is 2 minus x squared, divided by x plus 5, is equal to 1. Well, what we can now do is take antilogs. Now that we've got a single log expression, the antilog of the left-hand side will just become the x terms sitting here without the log. And as we've got a base 4, if we raise 4 to the power 1, that's the antilog of this side. So therefore we get 2 minus x squared over x plus 5 must equal 4. Solving this is now an algebraic problem. Multiplying both sides by x plus 5, I get 2 minus x squared is equal to, I'm going to multiply it out as well, this is 4x plus 20. Multiplying that bracket out, we get 4. The underneaths, negative 2x and another negative 2x gives negative 4x and x squared. And that's equal to 4x plus 20. And therefore, bringing everything onto the left-hand side, leaving 0 on the right, we get x squared, well, that's the only one there. Negative 4x is joined by another negative 4x to give us negative 8x. And we've got a positive 4 joined by a negative 20, subtracting 20 from both sides, and we get negative 16, and that is equal to 0. It's tempting to attempt a factorization just by trying to pop the values into the two brackets. This will be x, this will be x. 4 and 4 minus to generate the negative 8, but we run into trouble here. Negative 4 times negative 4 is positive 16, and we need negative. So this ain't going to work. So what options have we got? We could use the quadratic formula, or we could complete the square. And I think my preference is completing the square. And to complete the square, we have to halve this coefficient and form the square bracket. So I get x minus 4 squared minus 16 equals 0. I've purposely left a gap here because, as you know, this will happily generate the x squared and it will happily generate the negative 8x, but unfortunately it gives us a positive 16, which we have to remove immediately. So we've got another negative 16 here. So therefore I get that x minus 4 squared minus 32 equals 0 is the completed square version of our quadratic here. The advantage of this is that it will pop out the roots very quickly. So therefore I can say that x minus 4 squared is equal to 32. Coming down here, we get x minus 4 is equal to plus or minus the square root of 32. So putting the 4 on the other side, we get x is equal to 4 plus or minus. Now, root 32 is the root of 2 multiplied by itself 5 times. Now, 4 of those root 2's can be converted to 4. And that's because the root of 2 multiplied by the root of 2 equals 2. So this becomes 4 root 2. So 4 of the root 2's are in here, and the last remaining one that can't be paired up is sitting here. But we're not quite finished. And the problem is we cannot take logs of a negative number. So if 2 minus x or x plus 5 lead to a negative number, this will not have a solution. So we need to test x. So x is equal to, taking our common 4 out, 1 plus or minus the square root of 2. And these are equal to, in decimal terms, the first one you get is 9.6568 ... and the other one, negative 1.6568. Now, because we cannot take the logs of a negative number, do either of our terms fall foul of that rule? X plus 5, well, with both of these values, this term is not in trouble at all. We're okay. But when x is equal to 9.65, which is the positive version of our two solutions, we are in trouble. We cannot take the logs of that negative number. That solution is out. So our only solution that works is x is equal to 4, 1 minus the root of 2. And that is your one and only answer.